Tricks! Hi there, hi there, hi there. It is a Tuesday and Tracy is wiping her glasses. And now she isn't. Hello, Tracy.
Thank you, Mimi. Good. Hello. That was not embarrassing at all.
Not
I
at all.
appreciate it.
How are you?
Fine, and you?
I'm good, thanks.
You've had too much sugar today, hey?
No, not today.
Are you sure about that?
Yeah,
Because
no.
it looks like it.
No, you don't know, man. Come on now.
Sorry.
What are
You're
we
just
doing?
excited. Okay.
What are we doing for the
What are we doing today?
Yes.
We're going to do projectile motion. Okay, grade 12s. This is new to the grade 10s, but the equations of motion, grade 12s, but the equations of motion isn't. All we're doing is going, instead of doing it horizontally, we're going to do it vertically. It's actually a really nice section, and it's guaranteed in your exam. Guaranteed.
All
Yeah.
right. You heard that, Matrix. Vertical projectile motion. Yes, that is the word. That is what we're doing today. Hope you guys enjoy the show. Make sure you hit us up on Facebook and on Twitter at Learn Extra. Check out our website, learn.mindset.co.za. Remember, it's the month of love. So we have a little thing going on Facebook. Please share your pictures with the hashtag Show Your Love. Share a picture of someone you love, or your pet, or your bicycle, or your pencil, anything, guys, and tell us why it means so much to you. And you might just see yourself on TV one day. You know, we're gonna post them on TV and make nice little things with little hearts and everything because it's Feb. But remember, you don't just show your love in February only. Throughout the whole year, you appreciate everybody in your life. Just a reminder, Tracy.
So I do worry about it, but it's okay. We'll just move on. She's obviously very excited about
No,
Friday, but that's
man.
okay. We'll have a chat just now, sweetie. Anyway, so we're looking at vertical projectile motion, which is exactly what it says it is, okay? It's projectile motion. It's in the vertical direction. So the first thing is, what are we going to do? Well, we're going to look at the equations of motion again, just to remind you of what they look like. We're going to discuss a little bit of vertical motion, and then we're going to do a little bit of graphs today. We are doing more graphs next week, so don't get too hung up about that, all right? But before we even go ahead and look at some theory, let's give you the challenge question, which will be posted. So the challenge question says, a stone falls from rest from a great height. After traveling a distance d in a straight line in t seconds, it has a velocity of v. At what time and distance during its motion did it reach a velocity of half v? Okay, this is a mean question, and it comes from an exam. So don't think you can't get this. This is absolutely level 4. This is way up there. So option A is time would be t over 4, distance d over 4. Option B, t over 4, d over 2. Option C, t over 2, d over 2. Option D, t over 2, d over 4. Don't guess grade 12s. This has been chosen specifically because you need to realize that in your multiple choice, don't guess multiple choice. It's a very big part of your exam. Okay, some of it is easy because it's straight theory. You don't need to stress about it, but this needs to be worked out. Okay, you are going to need to use your equations of motion. So the challenge has been set. Okay, don't guess. Obviously, we're waiting to get the answers. They can post A, B, C, D.
Yes, they comment right under the
Okay,
post.
great. So let's see how you guys do. I
Yes.
will answer it later in the show. Okay, so let's just deal with some of the theory that you need to know. First of all, what is a projectile? That's quite important. So a projectile is an object that is thrown or projected, look at that, into the air and then allowed to move under the influence of gravity. So basically it's a case of either we're dropping an object off a building or just dropping it onto the floor. I do it with a pen, but I'll get moaned at because this is an expensive pen. Or you throw something up into the air, but basically it leaves whatever gave it motion, okay, and then it's only acting under the influence of gravity. It's not a case of my pen as I'm moving it up and down. This is not projectile motion. Okay, it has to be moving under gravity only. Very important, the gravitational acceleration always, 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 I can't actually emphasize this enough, acts down. A couple of years ago, my learners wrote the prelim exam, and one of the questions in the prelim exam was about the direction of gravity. And because of the way the question was asked, probably 60-70% of them told me gravity acts up, which would be interesting because then we would all be floating in the air. And quite frankly, I like living on Earth. Okay, I know most of my learners don't think I live on the planet, but that's neither here nor there. You know, teachers are from a special planet, but we're not going to talk about that on TV because what's the word? What do they say? It's confidential. No, it's not confidential. It's classified.
Okay.
Yeah, it's like Area 52 in America. Moving on. Yes, maybe I have not had enough sleep for a while.
Sugar.
There we go. So, point is, acceleration due to gravity always acts down and is a constant 9.8 meters per second squared. That is actually a rounded value, but it's close enough to the real thing. Please be careful, grade 12s. Sometimes older textbooks will tell you that you can use 10, because for a while we were allowed to use 10 because it wasn't actually about the accuracy of the answers. Now we want to be more accurate, so you have to use 9.8. Also, remember it's on your information sheet, so you can't go into the exam and say, well, my teacher has taught me that it needs to be 10. Unfortunately, your examiner is not going to accept that because it's on the information sheet. So it's 9.8 meters per second squared, and it always acts down. Now, whether it's positive or negative is going to depend on your sign convention, so be careful there. Then, the next thing we need to look at is a concept called terminal velocity. An object can only reach terminal velocity when it's thrown or dropped from a high enough height. Okay? Parachutists, skydivers, those sort of people often reach terminal velocity, and terminal velocity is what happens when the person or the object is falling through the air. And remember, there's air resistance. Most of the time we ignore air resistance because it makes life easier, but there's air resistance as they're falling down. So gravity's pulling them down, air resistance pulls them up, and when those two forces are equal, the person stops accelerating and reaches their maximum velocity, which is called terminal velocity. They cannot, or that object cannot go any faster than that. But it can only happen if they are high enough. So it's very rare in, you're not going to have a stone thrown off a 3-story building reaching terminal velocity. It's not high enough, okay? Then, the equations of motion. The equations of motion are given on your information sheet. I'm just going to remind you what the different things mean. So VF is final velocity, okay? Final velocity, which means it's measured in meters per second. VI is initial, you can see from the I, okay? So it's initial velocity, and that means it's also measured in meters per second. A is acceleration, and that can be acceleration due to gravity. Some of you might be told by your teachers that you can substitute A for G. That's fine, though I'm a little hesitant because sometimes it actually isn't going to be accelerating due at 9.8, so just be careful with that. If it's acceleration due to gravity, then it is 9.8. Remember, that's in meters per second squared. T, and this is all getting nice and messy, but that's okay, is time, which is measured in seconds. Okay, so that's quite easy. What you need to be careful of is delta y. On your information sheet, it's probably going to put delta x, okay, but you can substitute delta x or delta y. They both mean displacement. Now, it's delta y because we're looking at displacement in the y direction, in the vertical direction, like in maths. Remember, in your Cartesian plane in maths, you have x and you have y. All right, so it's the same thing. So we're looking at y direction, so that's why it's y. Okay, so displacement, which is measured in meters, would then be vi delta t plus a half at delta squared, a delta t squared. I'll say that for you. I will show you in the next, in the question we do, how to work out which equation you need, but you'll use these. Grade 12s, I pretty much only ever use these three. It's a personal thing, okay? This equation can get a little sticky sometimes, but that's up to you, okay? Remember, this only works if your acceleration is constant, so it's constant motion. Be very careful with that one. Then, we can draw a whole bunch of graphs for vertical projectile motion. position time, velocity time, acceleration time. They're very important, okay? But the thing about these graphs, and we'll talk more about the shapes next week, is what we can create, what we can calculate from them. So the gradient of a position or displacement time graph gives me velocity. The gradient of a velocity time graph gives me acceleration, and the area under the graph gives me displacement. The velocity time graph is extremely useful. Those are the nice ones to work with. And then with an acceleration time graph, the area under the graph gives us velocity. The nice thing is your acceleration time graphs for these pretty much always look the same because you only have one sort of acceleration. You've just got to decide whether it's positive or negative. Okay? So pretty much that's the basics that you need. This section really is about practice, practice, practice. There's not a lot of theory. This is just about choosing direction as positive. Make sure you know which direction, and you stick to it. You're not allowed to change that halfway through just because it's convenient or you don't want to use a negative number. You don't have that option. Okay? You've got to stick to that. Okay? So, Looney, now that we've given them a bit of a basis, I think we'll take a break and then we'll jump right into some questions.
All right then. Mindsetters, we are going to take a break, so don't go anywhere. We'll see you straight after this. Welcome back, Mindsetters, from that break. Some young shout-outs before we start. Have Nico, Letukutula, Akani Mercy, Buitumelo Karabo, Mohlalefi Nombu, Siabulela Emmanuel Rialeboha, Vuyani Kachiso, and Leah. Have they, guys? Have they? Tracy?
Wow, I'm so glad she had that list. Please don't take this personally. In fact, we're 3.5 weeks into term,
Yeah.
and I have children who are still correcting me.
With,
and it's not
with
just
names.
Yeah, and it's please, it's not just the.
Yeah, no, I also struggle sometimes.
How do I say this without being politically incorrect? The black names, but it's also
Oh,
like the foreign country names where
Yes.
like they say no, ma'am, it's presented like this, and I'm like going, that is not how it's spelled.
Yeah,
You know,
sometimes.
and in fact, I got one kid who very graciously lets me call him by his second name because his first name's got a Q in it.
Oh, okay.
So that means it's got that clicky
Yeah.
sign. He's from Zimbabwe, and I'm like,
No, it's
never
fine.
going to happen, my boy.
Thanks.
This tongue, she don't work like that. Okay, you know, we have these moments. So it's, I'm glad you got the chance to butcher them.
Yes.
Anyway, so let's do improve your skills. All right. Now, this is from the February-March 2012 paper. They're always great papers. I love the supplementary papers. And it says to us, a stone is thrown vertically upwards. Now, what I'm going to do, grade 12s, and this is the important thing, is I'm going to pick out the important information. So all the stuff I write on the board, it's not just because I'm trying to show you something, so it looks nice on TV, but this is actually what I would do with the question if I was answering it on paper. So this is what I would do on my question paper, okay? So it's thrown vertically upwards at a velocity of 10. So that's VI, okay? From the top of a tower, which is 50 meters high. After some time, the stone passes the edge of the tower and strikes the ground. Okay, ignore the effects of friction. Yay, we like that, no friction. So, they give us a diagram, even better. So, we have a nice diagram which says my initial velocity is VI of 10, and what's actually going to happen, I'm just going to draw it over here, my stone's going to come up, and then it's going to go down. So, we need to remember it's first going to go up, it's going to stop at the top, and then it's going to come down. First thing I need to do, before I even decide or look at the next questions, I need to choose a direction as positive. Some of your teachers may be saying to you, always choose down as positive. Some of your teachers will be saying to you, always choose up as positive. There's nothing wrong with that, okay? But what I teach my learners is I say to them, choose the original direction of motion as positive, okay? Because then you don't have to think, am I choosing up, am I choosing down? Doesn't matter. So they threw it up, so that means I'm choosing up as positive, okay? So VI is 10. This means that for the whole motion, acceleration due to gravity is minus 9.8 meters per second squared because it's down, okay? First question, well, we get here and it says, draw a labeled free body diagram showing the forces acting on the stone during its motion. Well, it's left the hand, so there's no more hand on it. It's a projectile, which means the only force acting on it is gravity, which is Fg, and this has to be a labeled free body diagram. So we say that Fg is the force of the Earth on the stone. Okay? We need to explain what Fg is. That's its weight. Done. Nice and easy. Now it says calculate the time taken by the stone to reach its maximum height. So I'm just going to redraw over here what we were given. This was 50 meters from the height. Okay? And it goes up and it starts at 10 meters per second. And what they want is what is the time it takes to get to the top. So we need to recognize that, well, my initial velocity is 10. Okay. My final velocity, I must write slower for the board, is 0, because when it reaches its maximum height, it's not moving. Okay. A, we've just said, because I've chosen up as positive, is minus 9,8. And what they want is time. So we look at this and we go, hang on, wait, that actually looks like the order of the very first equation of motion, which says to us that Vf equals Vi plus A delta t. Okay? So Vf is 0, Vi is 10. We remember that this is minus 9,8, and we have delta t. Now, if you've made a mistake in your signs and you go and put in A as positive, okay, and you keep Vi as positive, when you work this out, you're going to end up with a negative time. You cannot have a negative time, grade 12s, because it means that you've gone backwards. And as much as we would love to go back in time sometimes, we can't. So remember, the 10 will come over. That's minus 10. I'm just showing you all the math so you can see it. And I would go 10 divided by 9,8, and my delta t is 1,02 seconds. Okay? First one done. Now it says to calculate, now watch what it says, maximum height above the ground. Be careful here. Because what ends up happening is you go, okay, I've got to calculate height. Brilliant, I like it. So you work out delta y for this little piece. Excellent, that's exactly what you need to do. But you've got to remember that that's only part of the height. The stone's already 50 meters above the ground. We then throw it up and it goes an additional, however high that is, before it comes down. So what we're going to do is we're going to take all the information I've got over here and work out delta y. Now we say to ourselves, well, how do we do this without carrying down this 1,02? Because if we've got time wrong, then, life gets a little difficult if you've got time wrong, because maybe maybe you've made a mistake. So you absolutely can use this equation. Delta y equals Vi delta t plus a half a delta t squared. There's nothing wrong with that, grade 12s, okay? And if you do that and you plug in the numbers that we've got, your answer will be slightly different to mine. That's taken into account when it's marked, okay? I would prefer, though, simply because if I make an error in the question above, then I carry it down and it becomes a problem. But I can actually work it out using this equation. Vf squared equals Vi squared plus 2a delta y. Okay? I haven't had to use time, which means there's no issue that if I got time wrong. So now we go, that's fine. I know this is 0. V is 10, and it's going to be squared, plus 2 times minus 9,8 delta y. So that means we're going to have 100 over here, which I'm going to take over to the left-hand side, which is minus 100. And 2 times 9,8 is 19,6. And that gives me delta y. Okay, so we would now put this into our calculator, and we're going to go 100 divided by 19.6. And remember, we can't leave it as a fraction. We never leave anything as a fraction. And we get 5,10. Okay, when we round that off, 5,10. So delta y is 5,10. But that wasn't the question. The question said maximum height above the ground. So you need to add a little bit in here. Okay, you're going to say that the maximum height, so therefore your maximum height is going to be 50 plus the 5,10. Okay, so it's 51,0 meters. Okay, be careful, be careful, be careful. Now they say to you, now this is when things get lots of fun. Using the ground as reference, that's my 0 position, sketch a position time graph for the entire motion of the stone. So, we are going to sketch a position time graph using the ground as reference. We know it hits the ground, which means it's not going to go below 0. Okay. It started, so this is delta y. Okay. And this is time. And what I do know is it starts at 50 meters above the ground. I know that it ends up as... Oh, wait, it's a good thing I added. I hope somebody's screaming on Facebook going, Tracy, you can't add to save your life, because that's not 51, that's 55. My goodness, that was terrible. Wow. That's actually 55,1. Wow. You know what? Use your calculator, grade 12s. Please tell me somebody picked it up. No one's picked it up.
Well,
I make mistakes. I'm sorry, guys. Anyway, so it's 55. So that means this position here would be 55,1. Okay. And remember what's going to happen. And these are nice because this actually draws as it goes. It starts at 50. It goes up. It reaches the maximum height. And then it comes down. And there we go. And that maximum height, this should be a dotted line. It's not doing very well here. No, that wasn't what I wanted. That's... Oh, no. And now my board is just saying, I don't want to play with you anymore, Tracy. Okay, let's take this out. Wow. Okay. And let's draw a dotted line, pretend it's straight, 1,02 seconds. Okay, nice and easy. Oh, wow. On its way down, the stone takes 0,1 seconds to pass a window of length 1,5 meters as shown in the diagram. So you have your 50, then you have this 1,5 meters, okay? And they want to know, calculate the distance from the top of the window to the ground, okay? That's y1, and they tell you that the time to pass this little piece is 0,1 seconds. Okay, so now life becomes interesting, because in order to calculate y1, we're going to go backwards a little bit. If I can work out the velocity of the stone at the top of that motion, I can actually work out y1, because I'll know velocity and I know acceleration, and I can use the equation, this equation, and I'll show you in a second why I can use it. Okay. Because if this actually this actually becomes final, I'm going to use initial over here, and I'm actually going to calculate this displacement, okay? This little piece. And that little piece, minus 50, gives me y1. Okay, so just stick with me as to what we're going to do. So the first thing I want to do is I want to work out a velocity to do with the window. Okay, so we're going to go back here, and we're going to say, well, what I know with the window is I don't know VI, I don't know VF, I know A, which is still minus 9,8. I know delta T, because it's 0,1. And I know delta Y because it's 1,5. Okay? I want VI because it's at the top. So what we're going to do is we're going to go and we're going to use this equation saying that delta y equals VI delta t plus a half a delta t squared. Okay. We know delta y. Now it's coming down. So this is actually negative 1,5. Okay. Be careful here. Okay. I'm looking at the downward motion. All right. So that means it's negative 1,5 over here. We want VI. A is, okay, that's 0,1. This is a half. This is minus 9,8. And then that's 0,1 squared. And just for time, guys, I'm going to give you what the answer is. And we get that VI equals 14,51. Okay? 14,51 meters. Now, we still haven't actually got to where we want. So I know that at this point, it's going at 14,51 meters. Now what we want to do is we want to go, but how far has it actually traveled in terms of its total displacement? Because if I can work out what its displacement is, then I can actually work out what y1 is. Okay, now I'm actually going to do it in a different way to that I put in the answers in the book, in the notes, because I want you to see this. Okay, so if I go vf squared equals vi squared plus 2a delta y. Okay, so that's where I'm going to go. My VF is coming down at 14. Okay. My VI is 10 because it was 10 meters. It was 10, correct? Let's just see. Yes, it was 10 going up. This is 2. This is minus 9,8, and we want delta y. Okay, so when we put this into our calculators, actually no, before I do that, I want to show you something. So I'm going to just show you how you can do this in one step on your calculators. I'm going to take over, so this is 14,51 minus 10 squared, which is then equal to minus 19,6 delta y. So when I put this into my calculator, I'm going to go minus 14,51 squared minus 10 squared, all divided by minus 19,6. Okay. Ooh, no, that wasn't what I wanted to do. That's what I want, and I want that. Oh, good. I'm glad the computer is playing with me again. All right, so if we do this, so we're going to go, what? I'm going to go minus 14.51 squared minus 10 squared equals, okay, divided by minus 0.6. Okay, now I get a negative answer of 5,64. And I'll explain now what that means. So we get a negative answer 5,64 meters. Now, in terms of our original diagram, down was negative. So what that 5,64 means is that the top of the window is 5,64 meters from the top of the building. If I want to now work out what y1 is going to be, y1 is going to be the 50 meters for the building, which I should actually write as a 50 meter so you can see it. 50 meters minus the 5,64, and you get 44,36 meters. Okay, 44,36 meters. Now, if you go and look at the answers that I put into the notes that are online, it's done in a different method, but it's exactly the same answer. Okay? Sure, we're busy overloading your minds. We're going to quickly look at this question. Unfortunately, we don't have quite enough time to do it, but it's here for a reason. Okay, a boy stands at the edge of a high cliff. Silly boy. Not just they only make boys.
Yeah,
okay.
always.
At a high cliff. He throws a stone vertically upwards with an initial velocity of 10 The stone strikes the ground at a point below the cliff after 3.5 seconds. So that's time. The velocity time graph below was obtained from measurements made during the motion of the stone. So he's standing on a cliff. He throws the stone up. Stone hits the ground. That's what we're saying. There's a couple of things that this graph is saying. First of all, they are saying to you, up is positive. Very first thing in the question. How do I know that? Because my initial velocity is positive, my final velocity is negative. My final velocity will be down. You cannot change that convention. You have to use that. Number one. Number two, it's constant motion, which we expect. It's a negative gradient, so we're going to get a negative acceleration. This question is really important because now they say to you, use the information on the graph to answer the following questions. Whenever they say that to you, they mean use the graph, which means you're going to calculate things like gradient, you're going to calculate things like area. Equations of motion, not what they want. Be very careful. Now, the first thing they ask you to do is to calculate the acceleration of the stone between 2 and 3 seconds. So they're saying between this point over here and this point over here, where my velocity is -10 and -20. Soon as I've got a velocity time graph, that means I've got to use the gradient. So we're going to write it out like this. And we say, fine, we want acceleration. Acceleration is equal to gradient. Okay, which means it's going to be equal to the change in the velocity over change in time. Be very careful here, please, grade 12s. It's very easy for you to get into maths mode in this case and go x2 minus, or y2 minus y1 over x2 minus x1. There are no y's and x's on your graph. It's a VT graph. It's a velocity time graph. You must do the equation in terms of the velocity time graph. Okay, so be very, very careful here. And also, please try not to use the symbol m for gradient because that can be confused with mass, and we don't want you to do that. So they say between 2 and 3 seconds. We saw that the final velocity was -20. The initial was -10. Okay, and then we're going to go 3 minus 2, and we get -10 meters per second squared, but we don't actually leave the minus. The minus means down. So we get 10 meters per second squared down. And I'm hoping someone right now is going, hang on, wait, Tracy, there's a problem, because you said to us earlier today that acceleration due to gravity is 9,8. It is 9,8. But with a question like this, you use the information from the graph. If we had to do this now as a skills thing and say, well, where's the problem with this? The problem is you got 10. There's an inaccuracy in the values given. Okay? You cannot now go, well, I know that acceleration due to gravity is 9,8. That's what I've been told. That's what it is on the information sheet. I'm going to use 9,8. No, 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 no. For the entire question now, acceleration is 10 meters per second squared down, because that is the information from the graph. Be very careful. Now they said, which time or times is the stone moving at, now careful here, a speed of 5 meters per second. Speed means no direction. So we go back to the graph and we say, fine, speed is fine. So 5, that's over here. So it's at half a second and at 1.5 seconds. So when we write this down, we say, well, when t is 0.5 seconds and t equal to 1.5 seconds. Then they say, after how many seconds does the stone reach its highest point? So we go back to the graph and we say, okay, well, highest point would mean here in the little diagram I drew. Highest point means it goes up, gets to the top. At the top it stops. That means velocity is 0, 1 second. Okay? And back down we go. So t equals 1 second. Ooh, now comes the fun one. Now they say to you, determine the height of the cliff from which the stone was thrown. Okay. Height, asking for displacement. Okay? your displacement is your area under your graph, okay? So what we're going to do here, and I just want to rub some stuff out so I can show you what we're doing, is we're going to divide this into two triangles because it's the easiest way to do it. This is my first one, okay? And then here, and it goes to 3.5, is my second one. So this is triangle number 1. This is triangle number 2, okay? And what we're going to do here is we're going to work out this area, we're going to work out this area, and we're going to add them together, but I'm going to keep the minuses, okay? Very, very important. So when I go down here, I say find, determine area. So we want the displacement. So we want change in displacement, which is then going to be the area under the graph, okay? And we have two triangles. So I'm going to say, well, that means it's a half base times height plus a half base times height. And my first one, the base was 1 second, the height was 10. The second one, the base was 2.5 seconds because it went to 3.5, and the height was minus 25, okay? We put all of that into our calculator, okay, and I'm going to leave that up to you to do, just because I'm pretty sure you can manage, okay? And what we get is we get 20, this one's going to give me minus 26.25 meters because that was the displacement, which then means the height was 26.25 meters because that was the final displacement of my stone. Last question, and we're going to do this quick. Using the top of the cliff as the initial position, that was the important part here, top of the cliff as initial position, sketch the position time graph, displacement time graph for the motion of the stone from its highest position until it reaches the ground, okay? Now, sorry, I just want to go, we need negative here, okay? The initial position of the stone is where we're starting. So that was at 1 second. So the initial position was at its highest point. It goes down, and that's what we wanted. And what they wanted is over here, this was at 2 seconds, where, no, that's actually at 1.5 seconds. Not 2 seconds. Okay, I'll show you now. Because at 2 seconds, it would have reached its starting point. And then after 2 seconds, it's now actually gone below the graph. Okay, the thing here is they didn't want the first part of the graph. They only wanted this little part, and then this little part over here ends at 3.5 seconds time. And, oh, geez, and it just gets worse. And this is delta y in meters. And I think I have now thoroughly blown some minds. Sorry, grade 12s. I think it's time for a break.
Yes. Mindset is we are going to take a break. Hello to you. Itumeleng Conrad, Matete, Victor, Precious, Faith, Maboko, Haupalelwe, and Fatima. Thank you for tuning in. We'll see you straight after this break. Welcome back. Mindset is from that break. It is now time for the challenge question.
Okay, did anyone answer the challenge question? Do we have any options?
Did. Yes,
what did they say to us?
Okay, let's quickly check.
Let's have a look.
C. It would be C.
So
B, D, C.
So mostly C or D, hey?
B, D, B.
Okay.
Some young B's there.
Some little B's along the way. That's
yes.
Okay. Well, I'm not gonna tell you yet, but I think you'll be able to figure it as we go along. So I'm going to show you how to do this, okay? A stone falls from rest from a great height. So we have a stone, and I'm going to draw a little picture. Let's draw it over here. Okay, so here's my stone, falls from rest, which means initial velocity is 0. After traveling a distance d, so that's d, which would be my initial delta y, in a straight line, my time is now t seconds, and my final velocity is v, okay? Now they say at what time and distance during its motion did it reach a velocity of a half v? So let's look at what happens when my final velocity is a half v. Let's start with how we would calculate time. Okay, so we know that vi equals vf plus a delta t. I'm taking down as positive. Okay, vi is 0 because it is 0. We know that this is a half v, and we're going to add a, and we're going to have delta t over there. So what I'm going to do now, oh, sorry, I've got those the wrong way around. Wow. Guys, I'm not having a good day today, apparently. So let's try that again, because it says that this is vf equals vi plus a delta t. Okay, so vf is a half v, and this is 0 plus a delta t. So we've got a half v equal to a delta t. And what we need to recognize is right from the start, look at what I'm going to do over here. Okay, I'm going to do a little bit of an extra equation, that from my original, okay, I know that our vf was v, this was 0 plus a plus t, because it went to so v is actually equal to a times t. Okay, so over here, instead of v, I'm going to put a times t over 2. That is equal to a delta t. The a's are going to cancel, so that means I get my delta t equals t divided by 2. So first of all, right away, if you put a or b, obviously it's not an option. It's going to be c or d. Okay, so those who got c or d, you might have got it right. Then, if we now consider the displacement, okay, so now I'm going to look at vf squared equals vi squared plus 2a delta y. And what they said, well, that's v squared from what they told us. This is 0 plus 2a d. Okay, so v squared equals 2a d. Okay, using the new information, so I want to get to a half. I'm going to put a half, so this is my final, equal to vi, which was 0, so let's just write it in as 0. Okay, I'm putting it into that equation, so that's 0 plus 2a delta y. Okay, now watch here what I've got. So this means that I've got v squared over 4 equals 2a delta y, and v squared is equal to 2ad. Okay, so 2ad over 4 equals 2a delta y. Okay, now I'm going to show you what happens with the math. So this becomes 2, so I've got ad divided by 2 equals 2a delta y. When I take the 2a over, okay, so this becomes ad over 2 times by 1 over 2a. The a's cancel, and I get d over 4 for my new one. So d over 4 means the answer is D. I think I went way too quickly, but you guys can think through it. The answers will be published.
Yeah.
Okay, so Luni.
Question time.
Question time. Let me
Yes,
see if I
yes.
can help our wonderful learners. Let me get to a blank page. Yes.
Okay.
Listen.
From Trophy Maluleke.
Trophy. It's a nice name. Yes.
Why are we adding the 5.10 with the 50? Because when it covered 50 meters, it was acceleration downwards, and the 5.10, it was going up.
Okay. When we go back to that question, it's actually a very good question. So that was the first one we did, okay? So we go back here, and what we need to recognize is I know it was going up for the first part, and then it comes down, but the acceleration is down for the whole motion, okay? Because if the acceleration isn't down as it's traveling up, it won't stop. if acceleration changes direction, when I throw a stone up in there, it'll just keep going. Nothing will stop it from moving. So remember, it's first going to go up for a little bit, then it's going to stop, because you're throwing it up, it's going to stop, then it's going to come down. So when the fact is I needed to work out what this little distance was and then add it to the height it was thrown from, which is why I added the two together. I know the stone is moving in two different directions, but the acceleration is still the same, Trophy, because as it's going up, the acceleration is stopping it from moving. Okay, so it can stop at the top. Once it gets to the top, the acceleration is still down, but now it helps the stone get faster as it moves back to the ground. Okay, sweetie, I hope that helps. Yes.
All right, and then from Mukunyeletsi, why is A always minus 9.8 and not 9.8? Because I learned in grade 10 that it is 9.8.
Okay, its value is 9.8. Okay, so let me just get a blank page so I can. Okay, acceleration due to gravity as a magnitude is 9.8. Absolutely correct. Whether it's positive or negative 9.8 depends on the direction I have chosen to be positive for the question. Okay, remember that acceleration, maybe that should be a D, due to gravity always acts down, which means if I throw a stone up and I choose up as my positive direction, then acceleration due to gravity becomes negative because it's in the opposite direction, it's in the downward direction. If I choose down as positive, then acceleration due to gravity is positive. It's positive 9.8 in the positive direction, because it's in the same direction as my sign convention. So it is 9.8. You must just go with you've got to look at what you choose as the positive direction. Okay, sweetie?
All right, and then from Juliet Maputla, is it important to state that I'm taking up as positive and down as negative in an exam?
You only need to really state which one you're taking as positive, and for two reasons. You don't get a mark for going up is positive, but you forget, and I see this all the time, and it's not for any other reason than because you get quite flustered and you forget in the exam. I still do it. When I do a question and I write an answer, I always state up positive, right positive, down, whatever the case may be, because then it helps me remember that if I'm then working with values, anything down must be negative or anything up must be positive. It's just easier for me to remember. So just state which direction is positive, but it's for you. Okay, it's not a mark thing. You don't get marks for it, but it's for you.
All right, and then from Katleho, why is it that what is the region where a projectile will pass its initial position?
Okay, I think that's from the graph we did. Okay, so if we go back to my graph, which I've drawn, no, that one, there we go. So if we look at the graph, and the region where it passes its original direction is where the area under both sides of the graph become equal. So if I look at this, and this is actually easy to tell because we ignore air resistance, okay, and because acceleration due to gravity is the same, whether it's going up or down, it doesn't matter. The time it takes a projectile to go from its initial position to its height back to that time is exactly the same as the time it takes to go from its height back to its initial position. So if it takes 1 second to reach 0 velocity, then can you see it's back at its initial position when its velocity is now minus 10. It started at 10, okay, so it leaves my hand at 10. When it gets back to minus 10, it's actually at its initial position. Okay, so you can tell by looking at the velocities, so they must be the same, just in opposite directions, or looking at the time. So this is the time to go up, this is the time to go down and reach the initial velocity. Okay.
And then on Twitter, @tabang194 is asking, how do I know which formula to use since we have 4 different formulas?
Okay. That's why writing a list is so important. So I tell my kids, always write a list. So in any problem, you write a list that says this. Okay, first thing you write. Okay, and then you go, well, the equations of motion are these. Okay, this would be given on your information sheet. And I'm not sure I've got them in the same order, but it doesn't matter. Okay. Vi dot t. And actually, the better you know your equations, the easier this becomes, by the way. So delta y equals vi plus v2 over 2 delta t. Then I tell my kids, write a list. So say, for example, I tell you that the final velocity is 10, initial velocity is -3. We know that, and let's just say it's going up. We're going to make up as positive. Then that's not actually going to work with my numbers. So let's do this. Okay, that's -9,8. And I'm just making this up. Okay, and I say to you, calculate the time. Okay, then I go to the list and I do this. I take my pen and I go, okay, let's see. I have final velocity. I have initial velocity. I have acceleration. I want time. I absolutely can use that equation. Let's look at the next one. I have final. I have initial. I have acceleration. Doesn't have time in it anyway, so that's a silly one to use. So I can't use that one. We look at the next one. I don't have delta y. I have vi. I have a. Also, this one doesn't work for me because I don't have enough information. So you go and you tick it off. And then automatically I can see which equation I need to use. Okay, that's the easiest, and you get used to it the more you know the equations.
Thanks. And then Lebogang Mosinki is asking, when writing our equation, must we replace A with G, or is it not necessary?
Sweetie, I'm hesitant to say, because I know a lot of teachers use the G. I'm very hesitant to say that you should use a G, simply because the emphasis is on the fact that they give you the equations in the exam, and the equations are written with an A. And the thought is that if you're given the equation, you must use it as given. So I'm hesitant to say it's fine, okay? I just worry that they're going to penalize you because it wasn't the way it was given, because G is a very specific acceleration. So just be careful. I'm going to say rather use A, okay? Rather put an A in and know that it's -9,8. Yeah.
Okay. And then from Edgar Garabo, what if a statement is given and the examiner didn't mention ignoring the air friction?
Assume it. Okay. Assume it unless it's very obvious that unless they say to you, for example, calculate A, okay, and they give you final and initial and they give you time. Then go and calculate A like you would normally, but they probably will tell you to ignore air friction in projectile motion, okay, because it just makes it easier. And on that note, I have to say goodbye.
Yeah.
We're going to carry on with graphs next week, grade 12, so hang in there, okay? And I'll see you next week.
Tricks, it's been great, man. Thank you so much for tuning in. We loves you. See you next week, guys. Goodbye.